This video is about solving a system of equations using the graphing method, part 2. So today we are going to build upon what we did in the previous lesson. Each system will still have two equations that need to be graphed on the same coordinate plane. The solution is written as an ordered pair and is the point of intersection of both graphs. Today, we must get the equations into y equals form in order to graph. This means we need to add or subtract or divide in order to isolate y. So we're going to solve the equation in order to graph. So in number 1, our equation is 2x plus y is equal to 9. Right now we can't graph this because the y is not by itself. So first, in order to isolate the y, we're going to subtract 2x from both sides. Now remember that 9 and negative 2x are not like terms, so they're just going to be written next to each other. Y equals negative 2x plus 9. So in this case, my slope is negative 2 over 1. My b value is 0, 9. So I'm going to start my graph on the y-axis at 0, 9. I'm going to use my slope down to right 1. And I'm going to use that to fill across the entire grid so that I get a nice line to help me find my intersection point. Once I have all my points, I'm going to connect them to draw my line. And then I'm going to look at my second equation. My second equation is y equals 2/3 x minus 7. So in this case, it's already in y equals, so I can identify my slope as 2/3. My b value is 0, negative 7. So I'm going to start at negative 7, up 2 over 3, up 2 over 3. I'm going to continue that through the intersection point and then draw my line. So now that I have my two lines and I can see their intersection, my solution is that point of intersection, which in this case is 6, negative 3. Number 2, my first equation is y equals x plus 3. It's already in a y equals form, so I can go ahead and graph this. My m, because there's nothing in front of the x, that's like having a 1. So my slope is 1 over 1. My b value is the constant, which is 3. So I'm going to start my graph at 3, and I'm going to use my slope up 1, right 1, all the way across my graph. And I'm going to connect my points to make my line. In the next equation, I have 4y equals 5x plus 8. This time there's a number being multiplied with y, so I can't graph it yet. In order to get y by itself, I need to divide everything by 4 and reduce where possible. So y equals 5 over 4x, because I can't reduce, plus 2. So my slope in this case is up 5 over 4. And my y-intercept is 0, 2. So I'm going to start at 2 on the y-axis, and I'm going to go up 5 and over 4. I can only get 1 point on my graph, which is okay because it's an intersection point. So I'm going to just draw my line in, and my solution is where these two lines intersect. So in this case, my solution is 4, 7. Let's look at one more example. So in this case, I'm going to have to solve in order to get y by itself in both equations. So in the first equation, we have 3x plus y, negative 3x plus y equals negative 4. To get y by itself, I need to move over this negative 3x. So because it's negative, I'm going to add 3x to both sides. Y equals 3x minus 4. So in this case, my slope is 3 over 1, and my b value is -4. So I'm going to start at -4 on the y-axis. I'm going to use my slope up 3, right 1, all the way across my graph. I'm going to connect that line. My second equation, 2y equals -4x plus 2. In order to get y by itself, I'm going to divide everything by 2 because y was being multiplied. So y equals -2x plus 1. So I'm going to have a slope of -2 over 1 and a b value of 0, 1. So I'm going to start at 1 on the y-axis. I'm going to go down 2, right 1. And I have an intersection point, so I can connect my line. And in this case, my intersection point for my solution is 1, -1.